So example 3, now we're talking about a different kind of translation. We're talking about stretching and compression. Compression. Um, so, well, if you notice in the question here, for g of x, we're multiplying it by 2. So we're going to look at what happens when you take a function and you multiply it by 2. So we're first going to look at f of x equals absolute value of x with the domain -4 to 4, meaning we're looking at the absolute value function just between, on the left side, -4, the right side, 4, and everything in between. And then what happens when you multiply by 2, okay? And then how are the domains and ranges related? So let's take a look. So here, the f function is in blue, right? So when x is -4, y is +4, right? The absolute value of a negative is positive. When x is -2, y is 2. 0 is 0. Positive 2 is 2, right? The absolute value of a positive number doesn't change. The g function just takes whatever the y value of the f function is and multiplied it by 2. So the g function, when the f value is 4, multiplied it by 2, you got 8. So what happens is, for a equivalent x value, the y value is double. So in essence, if the y value is bigger by a multiplier of 2, it's going up twice as fast. Another thing to point out is slope of the f function is 1. It makes the slope of the g function 2. Um, this transformation is called a stretch because you are now stretching the function. It's moving up faster than it was. Okay? Let's take a look at the next part. Now, the f function is the same. The h function is, we're now taking f of 2x. So let's take a look at the difference there. It really has no difference. I'm sorry. Yeah, and it's actually the opposite of what we just saw. In that instead of the function rising faster, this one is well, it is rising faster, but we cut it off. Okay, because the x values um, are now, it's between a domain of -2 and +2. Okay, so we're really only looking at half of the domain. So in this case, the range is the same, but the domain is only half of what the original domain was. Unlike on the last one, where the domain was the same and the range doubled. Okay. All right, so it's a try it question, so pause, give it a try, and then come back. All right, so show that j of x is equal to f of 1/2 x is a horizontal stretch of the graph of f. And you can use the table to help you. So for this one, if I'm doing f of half in x, um, the first thing I'm going to do is figure out what is f of half in x for each function. So um, f of half of -4 is equal to f of -2. Again, the f function is absolute value, so f of -2 is really equal to +2 because f of -2 is half of, well, f of x is the absolute value function, so the absolute value of -2 is +2. So we're going to put 2 in here. Although I think I can type it in instead of writing it in, so let's do that instead. If I do the same thing with the next one, what is f of 1/2 of -2? Wait, I'm just pulling a number from the x column. And it's really like saying what's half of -2 is -1. F of -1 equals 1. What you see is the pattern is this column is half of whatever this column is. So I don't need to write that out every time. I mean, you can, but what's simply going to happen is the third column is going to be half of whatever this is. So half of 0 is 0. Half of 2 is 1. Half of 4 is 2. Okay? Um, so you can just simply say the table pattern and relationship between f of x and x, where f of x is half of x. Right, so then that pattern is going to be that stretching. That's essentially what that's saying there. You don't need to get as complicated as that, honestly, but just showing that there's a pattern between j of x and f of x. All right, so that was example 3.